All right. Good morning, everyone. I am going to start a timer because just like Mike could take up the whole time talking about me, I could take up this entire conference talking about beavers. So the point of my talk today is to talk to you about beavers and wildfire. And this is something I've talked about a lot, but don't worry, there is a lot of new information in this. It's not just Smokey the Beaver version 145. So, beavers and wildfire. I do want to take a little step back here and point out that beavers and wildfire is not exactly salt and pepper. It's not peanut butter and jelly, and for a long time, these weren't really concepts that people put in a sentence together or even necessarily thought about together. But beavers and wildfire are incredibly important, and the relationship there is one that we really need to focus on, especially as the climate crisis does not show a whole lot of signs of slowing down or stopping. But reeling it back in, someone's got to do it. I'm going to talk to you all about beavers just for a few minutes. So this is a pretty classic beaver-dammed area. We've got the beaver dam on the left. We've got a whole diversity of vegetation. There's fast water. There's slow water. This is a complex environment. There's a reason it's called a beaver complex. These are very complicated parts of the landscape, and they're resilient to disaster, and they're resistant to disaster. But unfortunately, this is not what we have in most of North America. Especially here in the western states, we have most of our streams looking a little bit more like this. They're simplified, they're degraded. Depending on which western state you're in, we've lost anywhere from 50 to 90% of our wetlands in just the last 200 years. That is a massive loss, and it's not just bad because we lost this beautiful part of the land, it's bad because we're losing the resilience that keeps our rivers healthy, even during these really challenging times. And fixing rivers is tough. Like, we're a smart species, and we're struggling to do this in many places. But luckily, there's another very smart species out there, and that's beavers, obviously. And beavers see a stream like this, and they can handle it. So they've had over 7.5 million years to refine their engineering. They move into these degraded, incised, not super well-functioning systems, and they build their dams. And these dams, they grow over time. We start with a small dam. It begins to pond that water. The water is not stopping. I want to be clear. They're not building miniature Hoover dams. They're building beaver dams. The water goes around them, over them, under them, through them. And they're not going to stop at one dinky little dam. They're going to make it taller, longer, stronger. They want more water. They want that aquatic habitat. Now, I ask this at every single talk I give, and I'm so excited to actually get the answer from this crowd. Put your hand up if you've ever seen a beaver in real life. Amazing. I'm never going to top this. There's no venue where I can get more hands than this. But maybe we'll still have a few hands go down on this one. Put your hand up if you've seen a beaver walking on the land, not swimming. All right, still a lot of hands. Amazing. For those of you that don't know, beavers are semi-aquatic rodents, super, super awkward on the land. This is an animal that's anywhere from 40 up to 110 pounds, body shaped like a bowling ball, web-back feet, little grabby hands, huge paddle tail sticking out the rear end. When they're in the water, they're extraordinarily safe. They are outstanding swimmers. They'll hold their breath for up to 15 minutes. They can get away from just about any predator. When they're walking on the land, it's not really a walk, it's a waddle. And they know that, evolution has taught them that. And so while the beaver damming is a part of engineering that a lot of us can see and recognize, I want to emphasize that it's not all they do. Beavers also dig canals. And these canals are incredibly important. Beavers go out and they excavate basically little micro-streams that radiate out from their ponds across the valley bottom. They connect to the whole floodplain. They connect upstream and downstream. And these micro-streams, they massively increase the area of influence that beavers have. In just a very short amount of time, they can transform even our simplest, most degraded streams into thriving, diverse wetland complexes. And that is an incredibly powerful thing. And that's something we have a lot to learn from. Now, the way that this actually works, I want you to think about that stream without beavers before they moved in. Simplified, degraded, not a lot going on. Compare it to the stream with beavers. You have a lot wider pond area on the top. You have all these little beaver canals acting like microstreams. This figure is looking down into the earth. So you can see those plant roots sticking down into the soil. Out here we have a really deep water table. Most of our plants are not able to access true groundwater, so they're reliant on soil water stores. If it's raining, if there's snowmelt, if we have infiltrating precipitation, the beavers, they don't actually show off in such a big and dramatic way because all the plants are being watered from above. And so you see greenery everywhere, and maybe you don't appreciate the beavers as much. But you appreciate them when there's a drought. Because as soon as we enter a drought, those degraded systems, they don't interact as strongly with their floodplains. They don't fill up the valley bottom with water. And all of the plants that cannot reach that little area of influence or cannot reach the deep groundwater, they start to wilt and wither and shut down. And that's not good. We're building up this huge ecosystem just to dry it up and leave it hanging. But that's not the case when we have beavers. Because they're so good at slowing down that water and storing it on the landscape, because these beaver canals reconnect them in a really big way to the entire valley bottom, the entire floodplain, it's like the entire earth is a sponge full of water. And even if we don't have rain, even if we don't have snowmelt, those plants can still access that water in the soil. And in some of my own research, I've seen this effect persist in Nevada for over 3 years. And it could have gone on longer. I don't actually know if the drought ended, which was a great thing. I'm not going to wish longer droughts on anyone. But the beavers were tough there. And then thinking about this now, thinking about the situation we find ourselves in, it's not just drought that stresses us out. It's fire. And wildfires are going to burn whatever is easy for them to burn. And that's dry material. And when we have these riverscapes that build up all this biomass when it's wet and then dry it up as soon as we enter those dry periods, whether it's a summertime drought or a long-term drought, that's fuel. And what used to be one of the most fire-resistant parts of our landscape has become a wick for the fire. You just have this enormous amount of biomass dried out and ready to burn. But that's not the case when we have beavers. Because they're so good at slowing water down during high flow, because that water is stored and available during droughts, because the plants are able to continue to drink it, they can stay green and healthy, and they are very difficult to burn. And this is not just a conceptual model. This isn't just something I whipped up in PowerPoint and have been pushing on people because I think it's true. This is something we see. We see this a lot. We see this in Oregon, in the Bootleg Fire, an incredibly catastrophic fire where thousands and thousands and thousands of acres burned. And it was really severe burning, and we really had a lot of damage done to fish populations. But where we had beavers building their dams, building their wetlands, managing that landscape, it stayed green during the fire. This is not regrowth post-fire. This is a patch of the landscape that withstood the kinds of flames that a lot of our own communities are not able to withstand. We've seen this in Wyoming, in fires where there's forests that have been struggling with other disasters, other challenges, beetle kill, drought, excessive buildup of understory fuels. We have incredibly fast fire ripping across the landscape, creating firestorms, fire tornadoes, fire blizzards. It's alarming, it's difficult, it's challenging. We're struggling to figure out how to deal with these megafires, but beavers aren't. Their wetlands are still fire resistant. They're still withstanding these incredibly challenging systems, and we have a lot to learn from that. And you don't even need a ton of beavers to see this. This site is up in Northern California, and these were the only beavers for kilometers and kilometers in either direction, upstream or downstream. And this was a severe fire. You can see those pine trees are burnt from roots to tip, not a single needle left on them. And yet, the beaver wetland stayed green. It stayed intact. And when I first visited this site, I was struck by how loud it was. Going up there, it was silent. You could only hear the wind going through all the dead trees. There were no bugs, no birds, nothing. But then I got to this site and there's fish jumping, there's splashing, there's bugs buzzing, there's birds calling, and the beavers are there grunting to their kits. So they didn't just survive it, but they're thriving here after the fire. They've been doing this for so long, and it's something that we really need to pay more attention to because we probably cannot get through the climate crisis if we do it all on our own. We have to work with nature. We've got nature's engineer out there showing us what they can do. We just need to listen. So what exactly is the state of the science? I've shown you all these photos. Clearly there is evidence that this is a phenomenon we should be paying attention to. But where are we data-wise? How much do we know? What do we not know? What do we still need to work on? What are those bits of information that can take this to the next level? So looking across the literature, and this is just the peer-reviewed literature, I want to say, there have been a number of studies looking at a handful of fires, mostly in the western US, one over on the eastern side in Canada. And these fires are all documenting these beaver-created fire refugia, these patches that are not burning despite incredible pressure from the flames around them. And looking at this, the authors of these studies, myself as well as others, we've tried to figure out exactly why are these beavers so good at creating fireproof patches. Sometimes, especially out west, we're seeing that the water storage is incredibly important. The ponding, the water table elevation, storing that in the soil, that's key. But out east, where the landscapes are just generally a little bit wetter, we're also starting to understand that the way beavers chew on trees, everyone's favorite behavior, and maybe least favorite if you're a city manager, that's super important. They need to turn over those fuels. They need to create these physically complex wetlands because that's also roughness for the fire. That also makes it hard to burn. And this is great, like there definitely should be more research here, but whenever I think about doing my own research, I want to make sure that I'm meeting the needs of the people who actually want to use that for something. So I looked at the fire danger maps from 2019, And one thing that stood out to me is that we have a lot of fire danger, for one. But also, there's not enough research being done on this in all of the places that are struggling with fire. And people want to know, does this work in my backyard? Does this work in my home? So to answer that question, something my lab has been doing is finding more fires, which, as you can guess, is not actually particularly challenging. This is not the part I needed a PhD to do. There's plenty of fires out there to choose from. And so far, we have put together a database of now 20 plus more wildfires that we're looking at, over 2 million more acres that we're searching and analyzing. We've mapped out over 3,000 more beaver dams so far, looking to see in all of these different landscapes, in all of these places stressed by fire, what are the beavers doing? And then we want to take it a step further and we want to ask why. Why is it fireproof? Or if it's not fireproof, why not? Under what conditions can we really rely on the beavers? And in what conditions do we maybe need to take a step back and think about additional ways to support them or to build up the landscape around them, or to use our own engineering brains to add to what they can do? Now, as part of this research, we are also looking back in time, and we're starting to think about, beaver dams are these dynamic structures. Beavers don't sit in one place for years and years and years and years and years, centuries without moving. They're dynamic. Dams are going to break. Dams are going to be rebuilt. They drain, they fill, and that's part of this story. So we really have two big questions in this research. Does the fire resistance vary by region? Can people in Alaska look at data from Washington and use that? Can people in Minnesota look at data from Colorado and use that? Or are the differences between these regions so fundamentally important that everyone needs their own case study? We also wanted to answer the question, how much does it actually matter if the beavers are there in that moment? Or does it matter that the beavers were there sometime recently? So I'm going to show you a couple of the sites that we've been looking at and point out some key trends that I'm seeing. So first off, let's talk active beaver wetlands. This means that the beavers are there, they're working, they're maintaining, they are in control of that landscape in that moment, and they are doing everything they can to maintain that aquatic area and that wetland habitat. And I want to start off by talking about Minnesota. Not just because I'm currently working in Minnesota, although this is great to point out I am working here, and there are beavers there that have not gotten the attention they deserve. But I want to point this out because Minnesota is kind of the opposite of what people think about when they think about beavers and fire. We think about western landscapes. We think about places that are super dry. Minnesota is not typically super dry. We have a lot of water there. We have a lot of bogs, a lot of swamps. Land of 10,000 lakes is our slogan, although I think it's actually closer to 15,000. We also have a lot of active beaver ponds. And about 100 years ago, we also had a lot of big fires, and we've had a few more fires in the more recent years. So I looked at a fire that burned in 2021 in northern Minnesota, and I looked at the beaver dams within that fire, and lo and behold, I saw very strong fire resistance, even in this generally boggy landscape, even in a place that's infamous for how many mosquitoes can spawn because of how much water we have. We had strong fire resistance around these beaver wetlands. Now on all of these maps that I show you, I'm going to show true color, and then I'm going to show my burn severity maps, where red is high severity and blue is low severity or completely unburnt. Another place that I want to point out and show you a little bit from is Alaska. We've probably all heard or thought about, in some capacity, beavers moving north. They are a climate tracking species, which means as their habitat becomes available in new places, they follow it. They've done this for their entire evolutionary history, and they are heading back up to the Arctic right now. And so the question naturally follows, what is happening in Alaska? This is a rapidly changing landscape. It is severely affected by climate change. How do the beaver wetlands function up there? Well, up there, all of these beaver dams, which I am denoting with these little black squiggles, they are also associated with wildfire refugia. We are also seeing reduced burn severity around the wetlands in Alaska. What about British Columbia? What about places that used to be a lot wetter and have only recently really found themselves in this increasingly dry and hot state? What about places that have heat domes that dry out all of the vegetation in the matter of weeks? Well, good news for British Columbia is that the active beaver ponds there are still working very strongly. We have incredible fire refugia. These habitats are being preserved across the landscape in a lot of places that we just haven't really looked before. And I bring this up because, yes, this is something that takes some remote sensing to do or some field studies to do, but if you just look in a fire scar, find a beaver wetland, at least from my research, I can tell you that over 90% of the time, you're going to find a patch of fire refugia. So what about drained or inactive wetlands? Like I said, beavers are not always there. They take breaks too. It's allowed. And when they're moving around, what is happening in the places that they've left behind? Some places beavers have been gone a while. So believe it or not, this is actually a photo of an old beaver wetland. And the only way you can tell easily is when you look at a photo of it from above and you see a perfect little curvy line of willows going across a great big meadow valley bottom. That curvy line of willows, that's the old beaver dam. And all those willows grew because the beaver had been cutting willow, putting it into their dam. It regrows from those cuttings, and you create this structure that persists well beyond the actual beavers themselves. So sometimes we have drained wetlands, drained beaver ponds, but they're routinely filling back up. In places where we have a lot of beavers and the population is more healthy, we see a more short-term dynamic of filled, drained, and if that's happening, what we've started to see is that they're really fire resistant. As long as the beavers keep coming back, as long as they don't leave it alone for decades and decades and decades, it's okay if they're gone for a year. It's okay if the pond drains. We see very strong fire suppression. Sometimes, though, it's not as easy for them to come back. Minnesota has had an interesting history with beaver policies. And in some places, it's been really difficult for beavers to reestablish in some of the places they had been historically. So these ponds that I'm showing you here, they were last full 18 years before the fire happened. So there was an 18-year drying period. But even with that absence, even with the incredible drawdown of all of that water, they still created these little shadows of fire resistance in the landscape. And I want to point out, this was a very hot and severe burn. That is solid dark red going across this landscape. That means it was a big deal fire. But where you had those beavers, even though it had been almost 20 years since they were there, we still had little shadows of fire resistance. And then in California, a very dry landscape, a place beavers are really trying to get back into for the first time in many places after 100, 200, 300-year hiatus. We have a lot of beaver wetlands that get established, and it's great, and this is 7 years before a fire hits. But then sometimes the landowner decides, I don't want those beavers anymore. And you get these situations where a portion of the beaver dams get broken and removed, and the beavers are trapped. And then on somebody else's property, the beavers are allowed to stay. And so you have these areas where there's active ponding next to very recently drained ponds. And in California, because it's so dry, because these beavers have not been established for as long, because their hiatus has been hundreds of years, not decades. 2 years before the fire, we had beavers on the upper edge of this stream, no beavers on the lower edge. And we saw the wick effect. So we saw where those beaver dams were removed, the fire ripped through that river corridor. But once it got up to where the beavers were still working, we did have fire resistance again. And this is something to be mindful of. When we do not allow the beavers to stay, when they are trying to reestablish and we push them back out, we can make the problem a lot worse for ourselves. And so giving them time and trying to work with people to live with the beavers and let them do the amount of engineering they need to create that longer-term fire resistance is incredibly important for us as we move forward and try to work with these as our partners in the fight against climate change. Now, as always happens in research, like you ask one question, and then you start finding these things, and you're like, ooh, that's another research question I can answer. So I'm going to show you just two interesting little case studies that I don't have a full analysis on, but I thought they were worth pointing out because they are kind of unique in how the beavers were interacting with wildfire. So up in the Arctic, we've got fires going, and Arctic fires are really challenging because when that fire moves through these landscapes, it is releasing a whole lot of carbon that was locked up in permafrost, that has been since thawed, and is now on fire. Especially if it's a really peaty landscape, this is a challenge. We don't want to exacerbate fire by burning the landscapes that used to hold back all the carbon. But they're on fire. And so the fire in this one is progressing downwards, and those little black wedges on the stream, those are the beaver ponds here. And I want to point out that as this fire moved through the landscape, it was coming down, moving straight downwards in the way this image is oriented. As it got to those beaver wetlands, it was not able to cross them. And so at least in some fires, we are seeing true modification of fire behavior by having longer strings of wetlands together, by having the beavers in a closer packed area with more water, more engineering. Those fires, especially up here, are not jumping across with tree crowns because there's not tree crowns up here. It's just little shrubby stuff. So we can see some evidence that fire breaking by beaver dams is also something we can start to think about and maybe operationalize. There's also beaver dam analogs being built, and I feel very lucky to be well connected in the restoration community and was keyed onto this site by Kevin Swift of Swift Water Design. We just had a fire burn this year in California, and there was one site in the middle of it that had BDAs installed. Now, BDAs are beaver dam analogs. These are our fake beaver dams we're building to try to mimic them. And just like sometimes beavers build really good dams and also build kind of not so great dams, sometimes BDAs are really, really good, and sometimes they're not so great. But I'm going to show you an example of some really good BDAs, because this fire ripped through the landscape. You're looking at true color right now. Hard to see things in true color, if I'm being perfectly honest. Much easier to see them in false color. So here, red is living vegetation, black is burnt landscape. And where those BDAs were built, that is pretty much the only spot within this fire perimeter that we have active intact meadow habitat. It's even more stark, I think, to look at where the moisture is, where that water is, because this is really coming back to water. And so red, we have very low moisture. Blue, we have incredibly high moisture. And once again, where those BDAs were built, where we had done some of the restoration, where the beavers were not yet able to thrive, we are starting to achieve some of what beavers are able to do across the continent, but we're doing it on our own, or at least with a lot of inspiration from the beavers. So looking at all of these case studies, looking at this data, I've now got this conceptual model of all of the things that we need to think about for beavers and fire resistance, which I'm sure I'll revise next year when I have more interesting questions pop up. But at least for now, I want to point out that there are both vegetation impacts we need to think about as well as water impacts. And some things take a long time to happen. For beavers to truly transform a landscape into a dynamic wetland habitat that's physically complex, that has gone through cycles of abandonment and recolonization, that takes time. But once it's there, it sticks. It's harder to undo that effect that the beavers have had on the landscape. We also have things like water storage, and depending on if you're in the floodplain or in the surface water system itself, this can be a somewhat short-lived effect. We can drain the ponds. We can take the water away. Now, water is great for fire resistance. Water does not burn. But if we take it away, we're removing that very, very strong fire resistance. Now, the good news about this conceptual model is that beavers do all of this. It's not a pick one menu. This is layers and layers of redundancy. And this is why beaver wetlands are so incredibly fire resistant, because every little bit of engineering they do has contributed to making landscapes that are naturally resilient to all sorts of disasters, flood, drought, et cetera, and that contributes to their ability to deal with things like fire. So what's next? Where do we go from here? You know, everyone gets all hyped and inspired, and it's like, all right, how do I act? Is it time to start airdropping beavers across North America again? No, it's not. We did this. This was a choice that was made and should not be made again. And the Idaho story is pretty famous, but there's a lot of Californians here. You are not off the hook. We definitely had a lot of posters from California Fish and Game at the time talking about how we could also drop these guys up into the mountains to help us with water. So there was this recognition that we needed their help. Our methods, I think, were maybe not the best. So this is not what's next. What I think is next is going back to thinking, where is there a data gap? Where do we need more information? I think about this in terms of fire, but it's not just fire. It's flood, it's drought, it's carbon, it's pollutants. It's so many different things that we've identified that beavers are doing that we like and that we want more of. But where's the data, and is it lining up with where people need that data? And so thinking about this and talking to some of my colleagues about this, we kind of realized that this is a bigger question than any one person can answer on their own. We want to look at this sort of alignment or misalignment between science and policy and management, and we want to do a better job of connecting people and organizations across regions. We don't want just the California beaver people to be in their bubble. We don't want just the Montana people to be in their bubble. We all love our bubbles. The community is great, but we need to go across regions better. And so it was feeling like we needed some sort of like a knowledge network. So we wrote a grant to the National Science Foundation to make a knowledge network, and they funded us, which is great. So upcoming, if you want to be part of it, this giant QR, that's for you. Me and some of my colleagues, Jonah, Sandra, Adam, Jordan, Alexa, a steering committee that has a surprisingly large number of people in this room on it. Maybe you in the future will be coming together to answer these questions, to build those bridges, to close the gaps, and to make this a more functioning research community. So I'm going to close by saying that this is great. We want to open up those lines of communication, but we have to be able to actually communicate to do that. So I always like to take myself out of jargon land and do my favorite science communication exercise. And this was a real challenge when I first did it. You have to describe your research or your goals using only words with 4 letters or less. No beaver, that's more than 4. No water, no creek, no stream, no river, no floodplain. A lot of words are not available to us. But if you can get your work down into words with only 4 letters or less, you can talk to anybody. And so I will close by saying that I have really enjoyed spending the last 10 years studying big pond rats with a flat tail that slow the rain down, keep it on the land, and help stop fire. So thank you for listening, and definitely ask me your questions afterwards. I'm pretty sure we're moving straight on, but you can absolutely catch me for questions afterwards.